in the grand cosmic ballet that unfolds around the magnificent planet Saturn. A multitude of worlds perform their silent orbital dance. Among these celestial partners, more than 100 of them, we find a particularly intriguing moon named Tethys. It is one of Saturn's larger inner moons, a sphere of brilliant ice that has been journeying through the cold, dark expanse of space for billions of years. Tethys is not just another rock in the sky. It is a key player in the story of the Saturnian system. It holds clues within its frozen surface that help us piece together the violent and magnificent history of our solar system's formation. When we look at Tethys, we are looking back in time, at a world shaped by colossal forces and the relentless passage of eons. Tethys is a relatively small world, but what it lacks in size, it makes up for in character. With a diameter of just over 1,000 kilometers, it is a sphere composed almost entirely of water ice. Imagine a world so cold that ice becomes as hard as rock, capable of preserving the scars of ancient impacts for an eternity. Tethys is one of the least dense objects in our solar system, suggesting that beneath its icy shell there is very little rock. It is essentially a giant, dirty snowball, reflecting sunlight with incredible efficiency. This high reflectivity, or albedo, makes it one of the brightest objects in the Saturnian system, a gleaming pearl against the black velvet of space. Its surface temperature hovers around a staggeringly cold -187 degrees Celsius. This world was first spotted in 1684 by the Italian astronomer Giovanni Cassini, who dedicated his life to observing Saturn and its companions. He used the powerful telescopes of the Paris Observatory to unveil 4 new moons, and he named them the Sidera Lodoicea, the stars of Louis, in honor of his patron, King Louis XIV. It was only much later that the moons were given their current names, drawn from the Titans of Greek mythology. Tethys, in the ancient myths, was a titaness and a sea goddess. This name is wonderfully fitting for a world that is made almost entirely of frozen water. A silent, icy ocean suspended in the heavens, waiting for us to explore its mysteries. The initial view of Tethys from our telescopes on Earth was little more than a faint point of light. For centuries, its true nature remained a profound mystery, a distant companion to the ringed wonder of our solar system. It wasn't until the arrival of NASA's Voyager probes in the 1980s, and later the Cassini mission, that Tethys transformed from a mere speck into a fully realized world. These robotic explorers sent back breathtaking images and data, revealing a landscape of dramatic contrast and epic scale. They showed us a world that was not just a simple ball of ice, but a complex and dynamic body with a story to tell. A story written in craters and canyons across its frozen face. The surface of Tethys is a dramatic testament to the chaotic history of the early solar system. It is a canvas covered in countless craters, each one a scar left by a collision with a comet or an asteroid. These impacts occurred over billions of years, pummeling the moon's surface and shaping its modern appearance. The most breathtaking of these features is the enormous impact crater named Odysseus. This single crater stretches for an astonishing 450 kilometers across, nearly 2/5 of the moon's entire diameter. If a similar impact were to strike our own moon, the resulting crater would be unimaginably vast. The sheer scale of the Odysseus impact is staggering. It must have been a cataclysmic event that nearly shattered Tethys completely. What is fascinating about Odysseus is that its features have softened over time. Unlike the sharp, deep craters we see on our own moon, the floor of Odysseus has rebounded and flattened out, conforming to the spherical shape of Tethys itself. This tells us something profound about the moon's past. It suggests that when the impact occurred, Tethys was warmer and more malleable than it is today. Its icy crust was perhaps partially molten or slushy, allowing it to slowly deform and relax over geological timescales. The crater's rim and central peak have also subsided, leaving behind a more subtle, ghost-like impression of the violent event that created it, a silent echo of a near-fatal blow. As if one colossal feature weren't enough, Tethys is also home to a gigantic canyon system called Ithaca Chasma. This network of valleys runs for over 2,000 kilometers, stretching from the Moon's North Pole almost all the way down to its South Pole. The canyon is immense, reaching up to 100 kilometers wide and several kilometers deep in places. It is a monumental scar that wraps around a significant portion of the globe, making Tethys look a bit like a cosmic cracked egg. The sheer size of Ithaca Chasma hints at an incredible geological event in the Moon's past, a force powerful enough to fracture its entire icy shell on a global scale. The origin of Ithaca Chasma is a topic of great scientific debate, but one leading theory connects it directly to the Odysseus crater. Some scientists believe that the shockwaves from the colossal impact that formed Odysseus traveled through the Moon's interior and literally cracked it open on the opposite side. However, a more recent and compelling theory suggests that the canyon formed as Tethys cooled and its internal liquid water ocean froze. As water freezes, it expands. This expansion would have put immense stress on the Moon's outer ice shell, causing it to rupture and form the vast canyon system we see today. If this is true, Ithaca Chasma is a frozen monument to the death of an ancient subsurface ocean. Tethys orbits Saturn at a distance of about 295,000 kilometers, placing it within the planet's main ring system, just beyond the bright A and B rings. It completes one full orbit around the gas giant in a swift 1.9 Earth days. This relatively close proximity to Saturn means that the planet would dominate the sky of Tethys, appearing as a colossal and breathtaking presence. From the Moon's surface, you would see the majestic ring slicing across the heavens, casting shifting shadows and reflecting a soft, ethereal light. Tethys is also tidally locked to Saturn, which is a common phenomenon for moons in our solar system. This means the same face of the Moon is perpetually turned towards its parent planet. This tidal locking has a profound consequence. A day on Tethys is the same length as its year. The Moon rotates on its axis in exactly the same amount of time it takes to orbit Saturn. So, if you were standing on the Saturn-facing side of Tethys, the great ringed planet would hang motionless in the sky, never rising or setting. Conversely, from the far side of the Moon, Saturn would never be visible. This gravitational lock creates a stable, predictable rhythm to the Moon's existence, a celestial waltz that has been repeating for billions of years. It's a dance dictated entirely by the immense gravitational pull of the giant planet it serves. The orbit of Tethys is also part of a more complex and fascinating gravitational arrangement. It shares its orbital path with two much smaller moons, Telesto and Calypso. These tiny moons are known as Trojans. They are trapped in gravitationally stable regions known as Lagrangian points, which lie 60 degrees ahead of and 60 degrees behind Tethys in its orbit. Telesto leads the way, while Calypso trails behind. These three moons are locked in a delicate gravitational balance, a cosmic ménage à trois, all circling Saturn together in perfect harmony. This configuration provides a living example of orbital mechanics at its most elegant and complex. This orbital resonance is not just a curiosity, it provides stability and tells us about the conditions under which this system formed and evolved. The presence of these Trojan moons suggests that the region around Tethys's orbit has been relatively stable for a very long time, allowing these smaller bodies to be captured and held in place. Studying this intricate dance helps scientists model the gravitational interactions within the Saturnian system and understand how such complex orbital relationships can arise. Tethys and its two small companions are a natural laboratory for testing our theories of celestial mechanics, a perfectly synchronized clockwork system on a planetary scale. The story of Tethys begins, as all stories in our solar system do, in the swirling disk of gas and dust that surrounded our young sun over 4.5 billion years ago. It is believed that Tethys formed from the sub-nebula of material that was left over after Saturn itself took shape. As this material coalesced, ice and rock particles clumped together, growing larger and larger through a process called accretion. Given Tethys's extremely low density and predominantly icy composition, it must have formed in a region of the Saturnian nebula that was very cold and rich in water ice. The small amount of rock it contains likely settled towards its center, forming a small, modest core. The Moon's early history was likely a violent one. Shortly after its formation, internal heat generated from radioactive decay and the powerful gravitational pull of Saturn may have been sufficient to melt its interior, creating a subsurface ocean of liquid water beneath a solid ice crust. It was during this warmer, more pliable phase that the Odysseus impact likely occurred. The subsequent freezing of this internal ocean is the leading explanation for the formation of the gigantic Ithaca chasma as the expanding ice fractured the surface. Tethys, therefore, is not just a static ball of ice. It is a geologically evolved world that has cooled and transformed over billions of years. Tethys holds a place of special significance for planetary science because it serves as a pristine record of the conditions in the outer solar system. Its heavily cratered surface is an archive of the bombardment that all planets and moons experienced during a period known as the Late Heavy Bombardment. By studying the number, size, and distribution of these craters, scientists can date different regions of its surface and reconstruct the history of impacts in the Saturnian system. Furthermore, its icy composition provides a sample of the raw materials from which the outer worlds were built, offering vital clues about the chemistry of the early solar system. In the end, Tethys is more than just a beautiful icy moon. It is a link to our own origins, a frozen world that carries the history of our solar system etched upon its face. Every crater tells a story of a violent collision, and its Great Canyon speaks of immense internal forces and a long-lost subterranean ocean. As we continue to explore the cosmos, worlds like Tethys remind us that even the most seemingly simple and desolate places are rich with complexity and wonder. Future missions may one day return to this icy pearl, to drill beneath its surface and perhaps find direct evidence of its ancient ocean, continuing our quest to understand the magnificent and intricate universe we inhabit.